Hey everyone, welcome to our second part. If you haven't seen the first section on density, I would encourage you to go back and watch it, where we just kind of introduce the term itself, some of the equations, and some of the units that it involves. So moving on into the next section, we can actually start to calculate density in terms of these real-life scenarios depending on the different objects that we may have. So in the first one, let's say that the objects are fairly regular objects. I'll show you a way on how we can go through and calculate those, and then we'll move to irregular objects after. So we can use things like scales to give mass, the mass of an object. So we can put an object on a weight scale and it will tell us what its mass is. And we can then calculate the volume of an object if we have the proper tools to do so. So if we have the proper means to figure them out. So for instance, I have a couple of shapes that are here. So I have a sphere, I have a cube, and a cylinder. And we have these little equations that kind of go along with each one. So these would be considered kind of our regular objects, and with each one, I have an equation that could kind of help me find the volume of that object. So for a sphere, it could be 4/3 pi times r cubed, so 3.14 times the radius cubed. I could have a cube where it could be just length times width times height. Or I could have a cylinder, which would be pi over 4 times r squared times the height, where r stands for the radius. So for our purposes, we're mostly going to be dealing with our cube shape, just to kind of make things, just kind of show you how they work, but not getting too complicated. You might see cylinders pop up every now and then. So when we start to find the density of water, we need to keep in mind that 1 gram is equal to 1 milliliter is equal to 1 cubic centimeter. So that's kind of an interesting concept, because really if I have kind of the scribbles that I made here earlier, if I have 1 gram, that tells me my mass, and that's equal to 1 mil, which is equal to 1 cubic centimeter, which is really a volume. I can start up an equation and actually calculate 1 gram and 1 cubic centimeter and find out that the density is just 1 gram per cubic centimeter. This tells me that the density for water is 1. That's my baseline. So if I have something greater than 1 for a density, like let's say that I have a rock, like something that you know it sinks. If I have a rock, that means that its density must be greater than 1. If it's greater than, it will sink. Similarly, if it's less than 1, it'll float. So if I were to put something on the top that I knew would float in water, like say styrofoam for instance, okay, then I know that's going to float on the top of the water, so its density must be less than 1. So really, water is kind of like our baseline to calculate a whole bunch of different things. So, question 3, we have a mass of a block is put on a scale, is found to be 20 kilograms, and it says if the block has a length of 5 centimeters, 10 centimeters, and 15 centimeters for a length, a width, and a height, then we can calculate the density, and what would that be? So pause the video, give it a try, see if you can come up with the answer, and we'll go over it in a second. Alright, so our first step that we should do, and hopefully you had a chance to give this a try, is to calculate the volume. So volume is equal to length times width times height. So volume is equal to, let's just pick our length is 5 centimeters, our width is 10 centimeters, and our height is 15 centimeters. So if I multiply those 3 things together, I'm going to end up with 750 cubic centimeters. That's my volume. Now from there, I need to use that information to then solve what the density is. So density is equal to mass over volume, and density is equal to, it gives me the mass of 20 kilograms, and then I need to use that information I just calculated for the volume at 750 cubic centimeters, and then I can do some division and calculate what this density is going to be. So if I were to divide those, I get 0.0267 grams per cubic centimeter. And so I could say at the end, because this is a word problem, what would be the density of the block? I could say the density of the block is 0.0267 kilograms per cubic centimeter. Now, I could ask another question here as well and say, well, what if we wanted to check and see if this thing would float or sink? It's a block and it's being placed in water. Well, this number would suggest that it would float because that number is smaller than 1. But keep in mind that number is also in kilograms. So a nice little ratio that we have for kilograms and grams is that in 1 kilogram, there's 1,000 grams. So I want you to quickly think, if we were to convert this thing grams per cubic centimeter like we just saw for water in that last slide, will this object float or sink? So 20 kilograms is really 20,000 grams. If I divide 20,000 by 750, I'm getting a number that's going to be larger than 1. So this object would actually sink in water. So hopefully you're able to kind of reason through how that works. So what if our shape has an irregular volume, like a rock for instance? If this has an irregular volume, then we can use this idea called water displacement. And you've probably known about water displacement without realizing what it was. If you've ever got in the bathtub before, for instance, you notice that when you sit in the bathtub, the water level gets higher. It's because the water is being displaced. It's the same volume of water in the tub, but it has to move out of the way for you to get in. So it's raising. So how much that water raises tells us a lot about the object that's getting placed into it. And so all we have to do to calculate for irregular shapes is we basically just need to know the measurement before the change and then the measurement after the object's been dropped into it. So really this one's a lot easier because it's just a subtraction. So if we know the mass of an object, we can find the volume, and then we can use those numbers to calculate the density. So I have question 4 here. We have a cylinder, has a mass of 10 milliliters of water in it, but when a rock is put into it, the new reading reads out 15 milliliters. So if the rock had a mass of 12 grams, what would the density be? Pause the video, give it a try, and come back when you're ready. Alright, so first thing we need to calculate is the volume. So volume is equal to, I kind of have an after reading and a minus a before reading. I need to know what the difference is. How much did it raise up? So it was 15 mils when I read it after. It was 10 mils when I started. So that means that my volume is 5 milliliters. Once I know the volume's 5 mils, I have a density equation that we've been using, mass over volume. Density, this mass was 12 grams. Over a volume that I just calculated out to be 5 milliliters, which means the density of this thing works out to be 2.4 grams per milliliter. Now again, I'm going to box this in, and if the rock had a mass of 12, what's the density? So the density, I need a sentence answer at the end. The density of the rock is 2.4 grams per milliliter. So we can calculate what the density is of an irregular shaped object using this idea. And again, same question, would think, okay, is this going to float or sink? Well, remember 1 cubic centimeter is equal to 1 milliliter, so really this is the same measurement, there's no conversions here. So 2.4 compared to 1, yeah, this object's going to sink in water. So hopefully you have all of the information that you need. As we go through the question, make sure that you're kind of showing your work. We have a conversion, just calculating what volume would be. We have an equation with some work plugged in. We have an answer that also has the right unit with it. And then we have a sentence at the end because I had a question that involved a word problem. So just making sure that you have all the right information when you're writing out your answer. So you'd be ready to move on to the activity part after the density notes and the video to move into the activity section.